Welcome students to another exciting class of matrices. Okay, today we're going to start with the multiplication of matrices. As you can see, the statement is given. It's written two matrices A and B are said to be compatible or confirmable for the product AB if and only if the number of columns in A is equal to the number of rows in B. If A is of order m into n or m cross n and B is of order n cross p, then AB is order m cross p and is defined as AB equals to CIK bracket close m into n, where we are going to go understand that part later. For let us understand what is row and what is column. Let us take this thing A, B, C, D. Okay, this blocks or buildings are known as columns. Fine. What are rows then? Rows are the floors in this building. They are known as rows. Okay, simple. So the building is known as column and the floors will you consider as rows. I think it's got clear. Okay, let us move on to the next thing. What is m cross n stuff? What is that? Okay, m cross n. Okay, I must drop this portion. M cross n. Now it is written m cross n. Now this m is representing number of rows. Clear? Okay. And this thing is representing number of columns. So what is m? Rows. What is n? It's column. Clear? Fine. Now for condition for multiplication, we need to understand. I'm rubbing this portion again very fast. Okay, now conditions for multiplication. Obviously in matrices. Pardon me my bad handwriting, I know that. Okay, so you don't have to comment that thing. Okay, condition for multiplication, as long as you're understanding the thing, understanding the concepts, fine. Condition for multiplication, it's written matrices, fine. Okay, number one, number of columns of first matrix should be equal to the rows of the second matrices. Okay, now see, A, it is m into n. What was m stands for? What n was representing? Number of rows, fine. And n number of column, fine. Okay, now A and B is going to get multiplied. For this, B's tummy got bigger, fine. For this, number of columns of A must be equal to the number of rows of B. If this condition satisfies, then they can multiply. This thing, we can get the product. Multiplication is possible. But if the reverse thing happens, what the case would be? Okay, we're going to discuss that later, but outcome will be of this thing, multiply. They can get multiplied, and after multiply we'll get the product. The orientation of elements will be in the form P, m is to P. So m of A will remain as number of rows, and P, which was number of columns in B, will become number of columns for the product AB. Clear? For the multiplication purpose, number of columns of A must be equal to the number of rows of B, and in the answer we are going to get number of rows of A and number of columns of B when we are getting the answer in the form of A is to B, AB, not A is to B, AB. Clear? AB. The most important and vital thing is, this thing is not at all commutative, What do you mean by commutative? Do you remember, guys? What is commutative? No? Don't remember? Okay, fine. Commutative means A into B, B into A. It is not commutative, so not equal. Might be equal, might not be equal, but AB equals to BA, it's not guaranteed. It cannot be. It cannot be. If the elements of A and B and the orientation is same, in that case we can get the same answer. Suppose A contains elements 1, 2, 3, 4. B also contains 1, 2, 3, 4. Okay. In that case, we can get the answer. Same. AB equals to B is AB equals to B into A or BA. Fine. So basic thing is it is not commutative. Not commutative. AB equals to BA. It's not commutative, so it's not equal. AB is not equals to BA. It is not commutative. Clear? AB is not equals to BA. It's not commutative. Let us take one example so that we can understand it clearly. I hope it's clear. Fine. Going to understand that first. Okay. A matrix. A matrix contains 1, 2, 3, 4. Suppose B contains A, B, C, D. A, B, C, D. A contains 1, 2, 3, 4. B contains A, B, C, D. Fine. Good. Multiplication possible? Obviously it is possible. It is 2 into 2. This is obviously it is 2 into 2. So multiplication possible. Number of columns of A is equals to number of rows of B. So multiplication is possible. Let us do one trick. Let us increase. How many rows are there? 2 rows. How many columns are there? 2 columns. We could increase 1 column. Let us make it EF. Will it affect the sum? No. It's not going to affect the sum because number of columns of A is equals to number of rows of B. Number of columns of A equals to number of rows of B. So that thing is getting satisfied. That thing is perfectly okay. So obviously this thing can be multiplied. But in a reverse way, so AB is possible in this case. AB is possible, but not BA. Why? Why not BA? Because B's orientation, B's number of rows is 2, number of column is 3, and it is not matching with A, whose number of column is 2, number of rows is 2, number of column is 2, and this thing is not matching. So B into A multiplication is not possible. B into A is not possible at all. B into A is not possible at all. Okay. Let us do one multiplication and try to understand how to implement, how to do it. Let us take this thing 1, 3 minus 2, 0. Fine. And let me multiply it with 2, 4, 5, 1. 2, 4, 5, 1. Okay. This is A and this is B. This is A and this is B. Fine. This is A and this is B. I'm rubbing this portion also. Just taking a bit space here. Fine. This is A and this is B. We need to multiply. It is 2 cross 2. It is also 2 cross 2. So multiplication is possible. Absolutely possible. Fine. Let us do the multiplication. How to do it? I'm rubbing this thing also. How can we do the multiplication? Trick. It will become easier for you. Just write 2 and 5. Small 2 and small 5 here. Small 2 and small 5 for your benefit. For your benefit. Write it in pencil, pen, or better write it in pencil so that you can cancel it or erase it. Okay. Just multiply. 2 into 1. How is getting multiplied? It's going to multiply 2 into 1 plus 5 into 3. 2 into minus 2. Fine. 5 into 0. Done. Now erase this. We are done with this portion. This is what? This was the column. This was the column. This is the column. And this column is getting multiplied. It's multiplying a row of this side. Clear? Now this column is multiplying row of the first matrices. See? Row of first matrices, row of first matrices. Okay, we are done. Now let us shift our attention to second column. Now this second column is going to multiply the rows of first matrices, first row, then second row. Small. 4 into 1 plus 3 into 1, 4 into minus 2 plus 1 into 0, bracket close. Done. So we can write 2 into 1 plus 3, 15, 17, minus 2, 0, it will be minus 4. Absolutely fine. This is going to be 7. This is going to be minus 8. So this is going to be minus 8. This is going to be minus 8. It's clear? Good. So it was a bit easy. 2 cross 2, 2 cross 2. So let us take a biggie. Let us take a big one. Okay. Let me increase one more column. Let me add one more column to it. Say 0. Okay, not 0. 6. Fine. 5 and 6. Let us proceed. Similar way, similar thing. We're going to multiply. Why? Because, first of all, multiplication is possible or not? Yes, possible. It is 2 cross 2 and this is 2 cross 3. Number of columns of this equals number of rows of this. Fine. So its column can multiply its row. It's possible. So again, same thing, 2 into 1 plus 5 into 3, 2 into minus 2 plus 5 into 0, 4 into 1 plus 3 into 1, 4 into minus 2 plus 1 into 0, 5 into 1 plus 3 into 6. Hold on, doesn't make any difference, but still. Five into minus 2 plus 6 into 0. That's it. So it's becoming 17 minus 4. Next, 7, 8, minus 8. That side. 8 in 5, 23, minus 10. Clear? Great. Let us move on to the next sum. Next thing is, you've already learnt about it, is not commutative. Now the next question arises that is it associative? Is matrices, is it associative? Oh, not visible. Next question, we are going to ask ourselves that is it associative? We know that it is not commutative. That's proved. Now is it associative? Now things to understand. Is it associative or not? Yes, it is associative. Answer is yes, yes, yes. Condition. What is the condition? Condition is that A, matrices B, matrices C, all must be conformable or compatible. All must be conformable or compatible for multiplication. What? Conformable or compatible. Now what these words mean? Okay, leave it. Let us understand by looking at the sum. Now there are three matrices A, B, C. If you multiply A, B then the product, the answer will get multiplied to C. The answer it is going to give will be equal to A into B, C. So that is what does it mean? Associative. What does it mean is associative. And what about conformable? It means regarding number of rows and number of columns here. Suppose, okay, A is of the order 2:3. Okay, let us take simple 1, 2, 3. B is of the order of 2 cross 3. Fine. And C is of the order of 3:2. Or it can be 3:1. So number of columns of A is equals to number of rows of B. Whatever answer we are going to get, we are going to, whatever not answer, whatever answer we are going to get, but orientations formation will be 2 cross 3. Are you getting it? Yeah. We are going to get 2 columns, 2 rows and 3 columns. 2 of A and 3 from, we are getting from B. Orientation will be 2 cross 3. 2 rows and 3 columns. In the answer we are going to get. What will be the elements? We don't know. We are just trying to understand whether multiplication is going to happen or not, whether it is associative or not. Next comes 3:1. Again, number of columns of AB, is it equal to number of rows of C? Of course, equal. So answer A, B, C, we are going to get 2 into 1. Answer, we are going to get clear? Now same thing can happen from that side also. Let's put bracket here, we're getting this, and if I put bracket here, then also it's becoming same. How? Okay, let me rub this portion and let me help you guys in understanding it. Okay. So answer here we are getting 3, 3. Number of columns of B is equals to number of rows of C, number of columns of B, number of rows of C. So the product will be in the form of 2, 1. Number of columns of A equals number of rows of BC. So obviously the answer will be A, B, C form will be 2, 1. Visible? Not visible, okay. Visible? Fine. Done? Let us do few sums to understand. Okay, before doing, next thing is it distributive? Yeah. First let us ask ourselves, is it distributive? And if it is, then when? Distributive. Is it distributive? Yeah, it is distributive. Condition with respect to, only with respect to addition. A bracket B plus C is equals to A into B plus A into B plus A into C. Next thing, A plus B into C, we are going to get AC plus BC. Clear? It is distributive with respect to addition. Clear, guys? We are going to do the sums in our next session.